In this video, I'm going to demonstrate how to run a spatial interpolation. Specifically, I'm going to show you how to run inverse distance weighted or IDW. So you have the projected dissolve layer for both the years, and we will go to the spatial analyst toolbox and then the interpolation and IDW. If you're using Find tools and if you type IDW, you will see that there are a bunch of same IDW tools available. And this is very common. There can be tools with the same name in different toolboxes. However, their functionalities or output may look different and they may be used in different circumstances. For this specific lab, we are going to use the one in Spatial Analyst tools. As a beginner, I always recommend just going through toolboxes. You get to know the tools better. You can see what the toolboxes or other toolboxes are in each of the tool sets. And it also helps to avoid confusion if there are tools with similar or same names. So I clicked on that IDW. Input point feature should be the dissolve PRJ. Remember, it's very important that we have a projected layer. IDW will not work with a layer that's in geographic coordinate system. It has to be in a projected coordinate system. The Z value should be the daily mean of PM 2.5 concentration. So this is the value that it will use for interpolation. I will update this name to 2004. Remember, do not delete the whole path here. The output cell size will be 30, and that's because we are going to compare this layer with our national land cover data set later on. So we are going to keep the cell size similar to land cover data set. So we will leave the rest of the information as is. Let's go to the environment here. Here you will choose the processing extent as the buffer, the Chicago CBSA buffer area. So that will help us interpolate for the whole region. And after we are done, I'll show you if you do not choose this, what the output looks like. We are going to mask it out to the actual area. So what this means is why masking is different than processing extent. So in the lecture, we discussed that there is always an edge effect here when we are running the interpolation, and we want to avoid that edge effect. That means we don't want to have a lower accuracy along the edges. That's why we used a buffer so that we still have higher accuracy along the edges. But we actually don't need these extra areas. So before the tool spits out the whole output, we want to mask it out to the actual extent of the metropolitan area. Now we will just click the run. So the layer is done. You cannot see that because our other layers are switched on. So we will switch off these layers on the top, or you can just drag this to the top and you can see this is the interpolated surface. And if you compare it to the 2004, you can, and again, you have to drag the point layer on the top so that the point shows up. These are the locations, and you can see the values here. The white values are higher values, whereas the green values are the lower values. The range of values is not too high, so from 10.26 to 16.74, and again, these are the daily means. But it tells you like around the Chicago downtown area, the values are higher versus if you go away, further away from the main urban core, the mean concentration of PM 2.5 decreases. One of the weaknesses of IDW is this kind of a bullseye effect, And later on in advanced GIS, we learn about other types of spatial interpolation that are also accurate and where you can avoid this kind of bullseye effect. But IDW is pretty easy and simple to understand, so that's why it's still it is a popular interpolation method. So I was going to show you how the interpolation output looks like if you do not assign the spatial extent of the metropolitan area, and this you can see is the output, this rectangular output. I changed the symbology so that you can visualize the two layers. The top layer is the one without the spatial extent, so you can see my tool, I did not assign any processing extent. And the bottom layer is the one that you guys did, where we assigned the metropolitan area as the processing extent. So why does this happen? Because if you're not assigning the processing extent, the default extent that the tool uses is the bounding rectangle of the point data set. So here is the Chicago 2004 air quality data set, and so it's looking at the maximum X and the maximum Y, and it's kind of creating a bounding rectangle like this, and that's what it's using as is processing extent. So that's the default method, and we don't want that. We don't want a random rectangle like this. Rather, we want the whole metropolitan area as an interpolated surface, and therefore we chose that processing extent to create the surface.